Alright, so today we're going to be going over derivatives of log and inverse functions. So essentially, this topic is basically finding the derivative of these log functions and then ln functions. So for a log function, how you would set it up is basically the derivative of whatever's inside the log goes on the numerator, which in this case is 1 because the derivative of x is 1. And then on the bottom, you would put an x, which is just whatever's in here because it's an x, and multiplied by ln b, which b is whatever's between the log and the variable. And for ln function, it is a lot more simpler, which ln function basically for ln of the derivative of ln of x, the derivative of whatever's inside the ln goes on numerator, and then the non-derivative of it goes on denominator. So ln of, let's say, 5x squared, that would equal basically 1 over 5x squared multiplied by 10x, in which 10x could just go in numerator. And if you actually simplify it, I'm pretty sure that's 2x. So that would be the derivative of ln 5x2. Alright, so let's get on with some questions. So number 2 is function g of t is equal to ln 3 plus 2 squared. So for this, we're just gonna, set it up how the equation's supposed to be set up. 1 over 3 plus 2 squared multiplied by derivative of whatever's inside, which is gonna be 2t. So if we just put it all together, we're gonna have 2t over 3 plus 2 squared. And now number 3 is gonna be f of x is ln x squared plus 3x plus 5. So we're going to set up our fraction real quick. Let's find derivative of the inside, which is going to be 2x plus 3. And then for the bottom, we'll just rewrite whatever's inside, which is going to be x squared plus 3x plus 5. And that is your final answer. Of course, you don't really have to simplify even further. If you could, that's fine. But in this case, we can't. Number 4 is going to be function f of x is equal to x ln x minus x. So for this, we have to use the product rule for the derivative of this, and then minus x could just be minus 1. So product rule, if you remember, it is f g prime plus f prime g. So f is going to be x in this case, and g is going to be ln of x. So f is going to be x times g prime, which is going to be 1 over x, plus f prime, which is going to be 1 times g, which is going to be ln x. And then at the end, we're going to have minus 1, which is the derivative of x. And now if we just multiply it all out together, we're going to have 1 because x over x is 1, plus ln of x minus 1, and the 1's cancel out, so your final answer is really just ln of x, and that would be derivative of number 4. Number 5 is we're going to have function f of x is equal to sine ln of x. So for this, we're going to actually have to use the chain rule, and then we'll use the ln of x derivative rule. So by the chain rule, we're going to have cosine ln of x multiplied by whatever's in the inside, which is in this case going to be 1 over x, and that would be your final answer. Number 6 is asking us f of x is ln of x, sine squared x. So this is a case of we're going to use the ln rule, and then we're going to find derivative of the inside. So we're going to have 1 over sine squared x. Now if we find derivative of whatever's in the inside, we're going to have 2 sine x multiplied by cosine of x, because the exponent of 2 is the outside function here, and we're going to bring it to a front, and keep sine of x the same. And sine of x is going to be the inside function by the chain rule, and derivative of sine of x is cosine of x. So actually, if you multiply all this out together, and simplify it fully, we're actually going to get 2 cosine x over sine of x, which if you even want to simplify it further, we would get 2 cotangent x, because sine of x over cosine of x is tangent, and the other way around is cotangent. So 2 cotangent x would be your final answer. Alright, so now we move on to number 7, which is f of x is equal to ln 1 over x. So if we set it up, we're going to get 1 over x, which would just give us x. And then now we need to find derivative of 1 over x, which if we rewrite it as an exponent, we're going to have x to the negative 1 power. And derivative of x to the negative 1 power is going to be negative x to the negative 2 power. Now let's rewrite it actually. So it would be x times negative 1 over x squared. Now if we put everything together, the x would go in numerator, and then it would cancel out 1 power on the bottom. So we would actually be left with negative 1 over x as our final answer for number 7. Now number 8 is y equals 1 over ln of x. So for this, we're actually going to have to use a quotient rule. So the quotient rule, if you remember, it's f prime g minus fg prime over g squared. So we plug in the quotient rule, we're going to get f prime is 0 multiplied by ln of x, but that all won't matter because 0 times anything is 0. And we get f, which is 1, times g prime, which is 1 over x. And all that is going to be over ln of x to the second power. Now if we just simplify all that, we would get negative 1 over x over ln x squared. Now if we simplify it even further, we're going to get negative 1 over x ln of x squared. And that would be our final answer for a derivative of number 8. Oh, negative sign there as well. Alright, so let's move on to a few more questions. So actually, I want you guys to try these on your own, so you could pause the video and try them out, and then we'll get the answers. Alright, so let's look at number 10. Number 10 is function g of t is equal to square root of 1 plus ln t. So we rewrite that real quick. 1 plus ln t. That is to the half power. So by the chain rule, we can set this as one variable. Let's just set it to u. So u is equal to 1 plus ln t. So we would have u to the half power and times u prime, which is going to be the derivative of whatever's inside. If we find derivative real quick, we get a half times u to the negative half power multiplied by u prime, which is going to be derivative of 1 is 0, derivative of ln t is going to be 1 over t. And now we need to simplify this. First, we have to actually plug in for u. So if we plug in for u real quick, we will get 1 over 2 radical 1 plus ln t. And that's going to be multiplied to 1 over t, which is, you could just put the fractions together. But that would be your derivative for number 10. So now number 11 is function f of t is ln t squared times sine t. So for this, we're going to have to use the product rule, which is f g prime added to f prime g. So for ln t, we're going to have to use the chain rule. And for the derivative of sine of t, we could just cosine of t. So we write f out first, which is going to be ln t squared and that's going to be multiplied to g prime, which is going to be cosine t, and added to f prime, which is going to be 2 ln t times the inside, which is ln of t, which derivative of ln t is 1 over t. And that's going to be multiplied by g, which is just sine of t. And you could realistically leave your derivative just like this, as we can't exactly simplify anything. So, we have all this, and then we have all this by the product rule. So, essentially, this would just be your derivative for number 11. So for number 12, we have ln, and then square root t squared plus 1. So for this, we're going to use ln, and then we might use the chain rule here in the inside. So it's going to be 2 rules we're going to use for number 11. So ln radical t2 plus 1, we're going to start with 1 over radical t2 plus 1 multiplied by the derivative of the inside, which is radical t2 plus 1. But let's actually write that out. T2 plus 1 is to the half power since it's a radical. So we're going to use the u rule here. So it's going to be u to the half power multiplied by u prime, which we could just figure that out right now. That's going to be 2t. So now all we need to do is just plug in for u, which is going to give us 1 over radical t squared plus 1 multiplied by, we have to find derivative u to the half power as well. The derivative of u to the half power, remember, is 1/2 u to the negative half power. So we have multiplied by 1 over 2 radical t squared plus 1, and t and the plus sign look exactly the same, multiplied by 2c. So you could, of course, put all these together. That would just probably give you, 2t in the numerator, and then I believe just 2t squared plus 1 denominator. But that is your final answer for a derivative number 12. Let's draw a line over here to separate the questions. So for number 13 is y equals log 8 x squared plus 3x. So this is the first log questions we're looking at here. So if we remember, the log or derivative rather is going to be, let's say on the top f prime, or it was 1 over x ln b, which the x is whatever is inside, and then the 1 is referring to derivative of the inside. So we just substitute those numbers. We get 2x plus 3 on the top, because that's the derivative of whatever's inside, times whatever's inside, which is going to be x squared plus 3x. That's on denominator, times ln b, which b is referring to this number right here. So that's going to be, put that in parentheses, it's going to be multiplied by ln to the 8th. Yeah, ln 8. And that would be your final answer for number 13. And for number 14, we're also dealing with a log function, so we could just do the same thing again. So on the top would go the derivative. The derivative of secant x is secant tangent. So we should write that secant times tangent x. And then on the bottom will go secant x multiplied by ln of 10. Now what we could do is actually simplify it. Since there's secant on both top and bottom, cross them out. Your final answer is just going to be tan x over ln of 10. And that is your final answer. Alright, so now for number 15, we have function f of s, ln of s. So for this, we're actually going to have to use the ln rule twice. So it's kind of like, your same rule twice, over and over again. But so we'll have for the by the ln rule, we'll have 1 over ln s multiplied by derivative of the inside. So a derivative of the inside is 1 over s. And multiplied by derivative of the inside, which is s, which is just 1. You don't really have to put it, but you could just for visualization purposes. So your final answer would be 1 over ln s multiplied by s. So that would be your final answer. And now final one is p as a function of t is equal to ln v over 1 minus v. So for this, we're going to have to use the quotient rule, which is f prime g minus fg prime over g squared. So for this, what we're going to do is f is the top, g is the bottom. So f prime is going to be 1 over v multiplied by g, which is 1 minus v, minus f, which is going to be ln v, multiplied by g prime, which is going to be negative 1. All of that is going to be over 1 minus v squared. And now what we could do is we could actually multiply out the top. I wouldn't suggest multiplying out the bottom. I don't think it'll help. So if we multiply out the top, we're going to have 1 over v minus 1 and minus ln of v. And then on the bottom, we're going to have just 1 minus v squared, just because it doesn't really matter. If we multiply it out, it's not going to help us. And that would be your final answer for number 16. Alright, so I want you guys to try number 29, 32, and 33. So you could try those out. This is going to use the product rule. This you guys could find out what rules it's going to use, but it's going to use more than one rule actually. And you have to find out the first derivative and the second derivative as well. So derivative of the first derivative. So you can pause the video and try that. So let's take a look at number 29. Number 29 is y equals radical x multiplied by ln x. So if you rewrite x, it's going to be x to 1/2 power, just because I don't like dealing with radicals or fractions. So x to the 1/2 power. Now we're going to use a product rule, which is fg prime plus f prime g. It is a really good strategy to write out the formula when you answer a question, just so you don't make any mistakes, and it's a good way to memorize it. So f is going to be x to the 1/2 power multiplied by g prime, which is going to be 1 over x. ln of x is 1 over x. And then multiplied by f prime, which is going to be half x, negative 1/2. And multiplied by g, which is going to be ln of x. And one thing to note that I've never really said is that it's always good to remember that the derivative of x to the 1/2 power or radical x is always like half x to negative 1/2 power, because it's something you're going to use a lot, especially if you don't like dealing with radicals. So I don't know why I crossed that out, but now we're going to simplify this. So on the first part, we have x to 1/2 power times 1 over x, which essentially that's going to be x to negative 1/2 power, because you have 1/2 minus 1, which is negative 1/2, and then that's going to be added on to 1, or we could just rewrite it as actually ln of x over 2 radical x, and this also is 1 over 2 radical x, or 1 over actually radical x, and this would be your first derivative actually. So we could rewrite that out. So 1 over radical x plus ln x 2 radical x, and that would be your first derivative. Alright, so now that we have the first derivative, we're going to have to find the second derivative. So let's rewrite this so it's, in a derivative friendly form, I guess. So we have x to a negative 1/2 power plus ln of x times 2, or radical, actually 1/2 x to a negative 1/2 power. So now we have to find the derivative of this. So we know the derivative of the first part, which we're going to use the power rule, which x to a negative 1/2 power. The derivative is going to be x to 3/2 power, and that we're going to put the 1/2, negative 1/2 in the front, so we have negative 1/2. And now for the second part, we actually have to use the product rule for this, which fg prime plus f prime g. So f is going to be ln of x, g prime is going to be, so we have to find the derivative of that. G prime is going to be 1 over 4x to a negative 3/2 power. So when you find derivative, you subtract 1 and 1/2. Negative 1/2 minus 1 is negative 3/2. And now that's going to be added on to f prime x, which is going to be 1 over x, multiplied by g, which is going to be half x negative 1/2 power. And if we write all of this out, just so it looks good, we're going to end up with negative 1 over 2 to the square root, square root x to the third power, and then plus ln of x, and actually it's going to be minus ln of x over 4 x to the 3/2 power on the bottom, and now plus 1 over x, or 2x rather, 1 over 2x radical x. And so that would be your final answer for the second derivative of number 29. Alright, so let's start on number 31 now. So 31, where we have ln and then secant x in absolute value bars. So for this, we're going to use the same thing, find derivative of the ln. We're going to have 1 over secant x, and multiplied by a derivative of the inside, which is secant x tangent. That's the derivative of secant x. Secant x tangent x. So now if we put it all together, we can see that we can cross out the secants, and we're just left with tangent x as the first derivative. And now for the second derivative, we want to find derivative of tangent x. So derivative of tangent x is just secant squared x. And that would be your second derivative for number 31, and the first derivative is tangent x. And now finally for number 32 is y equals ln 1 plus ln of x. So we're actually going to have to use the ln rule twice here, but so for the first derivative, we're going to have 1 over 1 plus ln of x. And then for the set, multiplied by whatever's in the inside. So derivative of 1 is just 0, plus derivative of ln of x is going to be 1 over x. And now what we have to do is we could multiply by 1, because what we would do is the derivative of the inside and then the derivative of the inside, which is this x right here. But the derivative of that is 1, and it would be unnecessary to put it here, but just for visualization purposes, your final answer would be 1 over, you could do x plus x ln x, and that is your final answer. That is the first derivative. Alright, so for a derivative of this, we're going to use the quotient rule for this, so it's going to get a little bit messy, but it should be mostly clean. So the quotient rule again is f prime g minus fg prime over g squared. In this case, we're not going to actually simplify out the g squared, just because it would be way too large for it to be necessary. So f prime is going to be 0 times g, which is going to be on the bottom. And we could just not write that out because 0 times anything is 0, minus f, which is going to be 1 times g prime, which is going to be 1 plus x times ln of x. We have to use the product rule for that. The product rule is fg prime plus f prime g. So by the product rule, we have x times 1 over x plus 1 times ln of x. And then now on the bottom we have, we did it correct. Yeah, on the bottom of this whole thing we have g squared. I'm going to leave it g squared for now. So this is all nothing. And if we simplify a numerator, we just simply have negative 1 be minus 1 because x times 1 over x is 1, and negative times 1 is negative 1, and plus or rather minus ln of x, and that would be over g squared. So our final answer, I believe, would be we do it negative 2 plus ln of x over x plus x ln x, and that is all squared, but we do not need to simplify that, just not necessary. And that would be your derivative for second derivative rather, for number 32.